Assalamualaikum and good day. We meet again in our first topic of the intelligence system course. Okay, now we look at the introduction to the knowledge-based intelligence system. So it will cover the intelligent machine or what machine can do. Then we are go for history of artificial intelligence from the dark ages to knowledge-based system. Once we go to the history, maybe we can appreciate what people have done until what we have today. And then next we have a summary. Okay, we are going to summarize all what we have go through in the history. Okay, intelligent machine or what machine can do. Okay, philosophers have been trying over 2,000 years to understand and to resolve two big questions of the universe. Okay, the first one, how does a human mind work? Okay, I think until now also we cannot exactly point how the human mind work. And the second question is, can non-human have minds? Actually, these questions are still unanswered until today, or maybe it's still it can be argued further more. Okay, in the dictionary, okay, essential English dictionary, intelligent can be derived or can be defined as is the ability to understand and learn things. Or the second one, intelligent is the ability to think and understand instead of doing things by instinct or just automatically. Okay, these are actually the uh, two kind of definition of intelligent. What the intelligent means, and this is by the essential dictionary, English dictionary. If you think back, okay, in order to think, someone or something, if we refer to the computer or non-human, uh, has to have a brain. You need to think, you need to have a brain. Or an organ that enables someone or something to learn and understand things. Okay, there must be a part, okay, or organ which that can enable someone or something to learn and to understand things. If you can learn or you can understand, then you can solve a problems. In order to solve the problem, it means that you can make a decision. So what we can conclude, we can define intelligence as the ability to learn and understand, to solve problem and to make a decision. Okay, this is the definition we are going to use for intelligence, means by intelligence. So the goal of artificial intelligence, okay, as a science is to make the machine to do things that would require intelligence if done by humans. So therefore, the answer to the question, can machine think, was vitally important to the discipline. So actually the answer is That's not as simple as yes or no. Means that uh, it is not definitely yes for a machine to be can consider to be think. Or you also cannot say no. It's not just as simple as yes or no. If you look back, some people are smarter in some ways than others. Okay, and these are all the criteria which be considered by the researcher before this in order to start developing an artificial intelligence. Okay, sometimes we make very intelligent decision, and we also sometimes make a very silly mistake. Okay, that is the human nature. You make an intelligent system, an intelligent decision. Also, at the same time, also you can make a very silly mistake. For examples, there are some of us which can deal with complex mathematical and engineering problems. But you also, the one that can deal with these complex mathematical and engineering problems also are not good in philosophy and history, but still we consider it as intelligent. Okay, and some people they are good at making money while others are better at spending it. This is quite an difficult code to be to be stand still. As you know, I think all the people are good in spending rather than making money. Okay, as humans, we all have the ability to learn and understand. Okay, as a human, okay, you can check yourself. Okay, you have the ability also to solve a problem, and you also can make a decision. A human also can make a decision, but you have to bear in mind that our ability are not equal and lie in different areas. When we say that human are intelligent, they can learn, they can learn, they can understand, they can solve a problem, they can make a decision. But these all criteria is not the same for a single human, and it's not at the same area. For example, in certain area, maybe you can understand, you can learn, but you cannot do them, you cannot solve the problem, you cannot make a decision. Therefore, we should expect that if a machine can think, some of them might be smarter than others in some ways. Uh, this code, this statement is why, how the development of artificial intelligence become interesting. Okay, later on we are going to look how it affect totally the uh, intelligence system development. In one of the most significant paper on machine intelligence, which the title is Computing Machinery and Intelligence, actually was being written by the British mathematician Alan Turing, and it is 50 years ago back, where it still stand up well under the test of time. Means can also uh, be used until today, being practiced until today, being experiment until today. where he considered that this is the father of artificial intelligence. And the Turing approach remains universal. Considered remains universal and can still be used to test any artificial intelligence. Okay, this is how we start to approach to developing to think of how we want to test of artificial intelligence. So he asks, is there thought without experience? Is there mind without communication? Is there language without living? Is there intelligence without life? Where all these questions, as you can see, are just variation on the fundamental question of artificial intelligence. Means that can machine think? The question is pointed to the question for the answer for the question, can machine think? Okay, Turing did not provide definition of machine and thinking. He just avoided semantic argument by inventing a game, the Turing imitation game. Okay. He wants to prove, but he didn't do any semantic input in word statement. So what he do actually, uh, he invented a game which can be observed artificial intelligence. Okay, so what was the game that he do? Where the imitation game we call Turing imitation game. Imitation game originally include two phases. We have two phases. In the first phase, the interrogator, there are three entities, interrogator, a man and a woman, where each of them are placed in a separate room, so they cannot interact directly. They cannot see each other directly. The interrogator's objective is to work out to identify who is the man and who is the woman by questioning them. Okay, you want to identify, okay, you have two room A and room B. Okay, which one is the man and which one is the woman? Uh, the man should attempt to deceive the interrogator. He is the woman. Try to answer all the questions to show that he is a woman. While the woman has to convince the interrogator that she is the woman. So, a man will deceive, woman will convince, and the interrogator need to confirm, need to identify which one is a man and which one is the. How is it identified? Is by throwing the question. Let them answer. Okay. So if you look here, okay, you have an interrogator, which is the one that decide between man and woman, who is where the woman is trying to convince the interrogator that she is a woman, where the man try to deceive, by answering that is not a man, is a woman. He is a woman. Okay, that is then how okay, this is a comparison. Okay, this is the first phase. So the second phase of the game, the man is replaced by a computer program to deceive the interrogator as what the man had did. Okay, now they take a computer which is programmed, and this computer is replaced with the man. It would even be programmed to make mistake and provide fuzzy answer in a way a human would. If you put a computer which you program it to make mistake to answer to provide a fuzzy, then if the computer can fool the interrogator as often as what the man has did, then he can say that the computer has passed the intelligent behavior test. So it has a certain limit of intelligence. Pass a certain limit of intelligence. So it didn't show any statement or any just by semantic, just by provide the game, show the game, and observe it. Then you can the system that you develop it is intelligent, has the certain intelligence. Yeah, so this is the second piece. The interrogator, you have a woman, and you have also the system that you develop. The computer with the program. As I mentioned, if you bear in mind that the first one, uh, we are not evaluating the interrogator actually. Okay? We are trying to observe the situation. The first one and the second one. When we replace the man with the artificial, sorry, with the computer, program it, and it can perform the same as what the man did in the first phase, then we can confirm that the system that you has passed the intelligence test. So it means that he has certain intelligence. So at the end of this, there are two. The Turing test has two remarkable qualities that make it really universal, become universal, even until today. So by maintaining communication between the human and the machine via terminal, the test gives us an objective standard view of intelligence. Okay, if you properly uh, provide the step, okay, so you actually can show that it achieves certain objective to verify certain intelligence. And the second one, the test itself is quite independent from the detail of the experiment because it can be a lot of other experiments which with the same structure as what Turing test game has been done. Okay, it can be conducted as two-phase game or even you can make it as a single-phase game when the interrogator needs to choose between human and the machine from the beginning of the test. These qualities actually is the one that we consider to develop artificial intelligence. It helps to develop artificial intelligence. So to test, is it possible to the machine to gain certain intelligence? Turing believes that by the end of 20th century, it would be possible to program a digital computer to play the imitation game. Okay, 50 years ago is already thing of that. So you can imagine how remarkable the study and done by Turing. Although modern computers still cannot pass the Turing test, it provides a basis for the verification and validation of the knowledge-based system. Even if not pass, but certain degree that we can validate of knowledge-based system. A program through intelligence in some narrow area of expertise is evaluated by comparing its performance with the performance of a human expert. Actually, this is the beginning of the knowledge-based knowledge-based system, expert system. Okay, because you cannot develop a system which are the same as human. But if you develop a system, a program which can narrow down the area of expertise which you can compare it with the human expert, then you can make a comparison of the performance. For example, you have a cardiologist expert in the heart diseases. You can identify the heart diseases. So you can provide programming a machine which can also you can compare it, the result between the expert and the machine, so we can measure the performance. We can make a comparing for the performance between the intelligence of system and human expert. To build an intelligent computer system, we have to capture, organize, and use human expert knowledge in some narrow area of expertise. So this is uh, the, the idea of the expert system. In order to build an intelligent system, you need to capture the knowledge of the expert, narrow the area and develop the database. Okay, this is the history of artificial intelligence. How, when the artificial and also artificial intelligence also have their dark areas where people don't disbelieve it, whereas the people are not believe it. I mean, cannot confirm the working of artificial intelligence, then there will be no research at that particular area, and no one to fund it, and so on. Okay, we look some of it. Okay, the birth of artificial intelligence actually started at 1943 until 1956. Okay, this is the birth. Who are okay? The first recognized in the field actually is the Warren McCulloch and Walter Pitts 1943, where they proposed a model of artificial neural network. Okay, they are the one that started the neural network and demonstrated the simple network structure could learn. Okay, they put a network, they develop a neural network, and they can show that this neural network can learn. Bucklock, the second founding father after AI, artificial intelligence, of AI after Alan Turing. The first one is Alan Turing. Had created the cornerstone of neural computing and artificial neural network. Bucklock is the one that started the neural network. Okay, this one we discussed it. As we know that John von Neumann, which considered as the third founder of artificial intelligence, and nowadays architecture of computer also based on this, based on his work. And later on, when two graduate students, Martin Minsky and Dean Ekman, which the one that developed the first neural network computer in 1951, which being supported by one human. Okay, another first generation researcher which doing the artificial intelligence is Clark Shannon, and he actually was graduated from the MIT, where later on joined the Bell Telephone Laboratory in 1951, where actually Shannon and Alan Turing shared the Alan Turing idea on the possibility of machine intelligence. Okay. Shows that can to as Alan Turing to identify the machine that we have been developed has certain intelligence. Where he published the paper on chess playing machine. Okay, where you know that when you develop a chess playing machine, a typical chess game which involve uh, more than 10,000 possible move. We have more than 10,000 possible move, okay, which this publication on 1950. Even if a new von Neumann type of computer, as I mentioned, okay, architecture of von Neumann computer like this, could examine, okay, if the capability of that computer which can examine one move per microsecond, it need to take about 3 million years to make its first move. Where this Shannon demonstrates the need to use the heuristic in the search for the solution. If you are going to study into detail, do research into detail of certain artificial intelligence, you may find that these heuristics are helpful in order to be developed. Heuristic method is useful in order to develop artificial intelligence. Okay, and then on 1956, John McAfee, Martin Minsky, and Clark Shannon organized a summer workshop at Dartmouth College, where during that time they only got only several researchers, I think only 10 researchers, which interested in study of machine intelligence, artificial neural network, and automata theory. Okay, but this is the beginning or the birth of of sign to a new sign which called intelligent artificial intelligence. There it is at 1956. Even though they started with only 10 researchers that involved in the workshop. The rise of artificial intelligence or the era of great expectation. This actually started in 1956 and the late 1960s, where the early work on neural computing and artificial neural networks started by McLeod and P was continued. Learning methods were improved by the Frank Rosen proved that the perceptron convergence theorems, demonstrating that his learning algorithm could adjust the connection strength of the perceptron. Okay, if you know the neural network, each of the neurons are connected and it can change the weight of the connected between neurons after the learning process. Each time it being learned, it means change the connection. So it can converge, make it separate converge. So in order to learn, it means that you need to have a data knowledge. One of the most ambitious projects of the era of a great expectation was the General Problem Solver (GPS). Okay, this is developed by Alan Newell and Herbert Simon from the Carnegie Mellon University, which considered as a general purpose program to simulate human solving method. And this is the problem. When you start to do everything and you want to be general, actually you are going to be failed. Newell and Simon postulate that a problem to be solved could be defined in terms of state. They use the mean and analysis to determine differences between the current and desirable or goal state of the problem and we choose to apply operator to reach the goal. The set operators determine the solution plan. Okay, as I mentioned, these two researchers they are focusing on general purpose program. That's why, however, as I mentioned, global purpose solution failed to solve complex problems. The problem was based on a formal logic and could generate an infinite number of possible operators. The amount of computer time and the memory that GPS required to solve a real world problem lead to a project being abandoned. So last day, actually, even though the theoretical background of the project is good, but it is not to solve a real problem since it requires computer time and memory, which are uh, not be achieved. In the 60s, AI research, artificial intelligence researcher attempt to simulate the thinking process of inventing general method for solving broad classes of problems. If that's where artificial intelligence uh, fail, when you try to solve a general problem, you are going to fail. Since you cannot I don't think that until a certain time also, certain feature you cannot develop to solve a broad class of problems, where the use of general purpose search mechanism to find solution to a problem, where the such approach now refer to the weak method, applying weak information about the problem domain. So by 1970, the euphoria about AI is gone. This is dark ages of the artificial intelligence, and which most government funding for AI project was cancelled. Yet AI was still a relative new field, academic in nature with few practical application apart from playing games. So to the outsider, the achieved result is seen as toys, as no AI system that at that time could manage the real world problem. Okay, actually, is during the dark ages of the AI. So during this time, it is failed. And what is the cause of the fail actually is the one that when you try to solve a general problem, the unfulfilled promise or the impact of reality is the dark ages between late 90s, 60 until early 1970. The main difficulties for AI in this time can be as 1960 were because AI researchers during that time were developing general method for the broad classes of problems. They were to solve a general method, a broad problem. Early program contain little or even no knowledge about the problem domain, especially when you don't have enough data for the particular domain, then it becomes more difficult. To solve program apply a search strategy by trying out different combination of small steps until the right one was found. And this approach was quite reasonable for single toy problem. So it seemed reasonable that if the program could be scaled up to solve large problem, they would find succeed. So it is until now also you are going to apply artificial intelligence AI, it is good to have a niche or narrow problem area to be solved rather than you have a general idea, general problem. Okay, many problems that AI attempt to solve were too broad and too difficult. A typical task for every AI was machine translation. For example, in National Research Council has funded the translation of Russian scientific paper after the launch of the first artificial satellite in 1957. Initially, the project team tried to simply replacing Russian word with English using an electronic dictionary. However, it was soon found that the translation required a general understanding of the subject to choose the correct word, where they found that this task actually difficult. So in 1966, all translation project funded by US government actually been cancelled. Okay, in 1971, the British government also suspended support for AI search, where Sir James Knight Hill commission had been commissioned by a Science Research Council of Great Britain to review the current state of AI. And he also found out that any major or even significant result from the AI research, where he found therefore so no need to have separate science which call artificial intelligence. It's not necessary to have artificial intelligence. Okay, now we go for the technology of the estate system or the key to success. Okay. This is between 1970 until mid 1980, which consider probably the most important development in the 70s was the realization that the domain of intelligent machine had to be sufficiently restricted. Previously, AI researchers had believed that clever research algorithms and reasoning techniques could be invented to emulate general human-like problem-solving methods. A general-purpose search mechanism could rely on elementary reasoning instead to find the complete solution and could use weak knowledge about the domain. This is about the estate system, the beginning of the estate system, and the criteria of the when weak method failed, a researcher finally realized that only way to deliver practical result was to solve typical cases in a narrow area of expertise, making large reasoning. Then we start to realize that if you try to solve cases in narrow area, then the success rate is higher. Okay? This is one of the successful development of the artificial intelligence using the estate system, which Condendro, which developed at the Stanford University to determine the molecular structure of the Martian soil based on the mass spectral data provided by a mass spectrometer. This is actually the project started by NASA. If you want to determine the soil from Mars, what is the structure, molecular structure? There was no scientific algorithm for mapping the mass spectrum into its molecular structure. Okay, such program was called later as estate system. So this is the beginning of the estate system. One of the successful story about estate system. So if you look back, actually it is based on the knowledge you put in the database. Okay, Dendro actually make a major paradigm shift in artificial intelligence, where a shift from a general purpose knowledge sparse weak method to a domain specific knowledge intensive technique. As I mentioned, when you make it narrow down to solve a narrow problem, then it become more success. Okay, the aim of the project is to develop a computer program to attain level of performance on an experienced human chemistry. So you need to have expert when you uh, try to acquire the knowledge of the expert, and it is based on the uh, specific rule. Okay, you will form a specific rule in order to review the expert system. Okay, then the project originated the fundamental idea of the expert system knowledge engineering, which encompasses technique of capturing, analyzing, and expressing in rules and expert. Expert will refer to the human expert. And then we have MyC. Okay, MyC also is an expert system. It's a rule-based expert system which used to diagnose the infectious blood diseases. Okay, it also provides a doctor with a therapeutic advice in a convenient, user-friendly manner. So uh, one of the criteria of the system, it can provide a reasoning. When it comes to conclusion, it will give a reasoning. Okay, why it comes to this conclusion. Okay, where my knowledge consists of about 450 rules derived from the human knowledge in a narrow domain through extensive interviewing. To develop all these rules, they need to gain a knowledge from the expert, and they need to interview the knowledge with the material, for example, the slide, whatever parameter in the blood that they can get. Knowledge incorporated in the form of rules would be separated from the reasoning mechanism. Okay, it is different. In knowledge, you develop the reasoning, and later on when you run the expert system, you will get the conclusion at the end with a reasoning. Okay. Okay, before I continue, there are a lot of other samples, example of the expert system here. But I'm not going to go through into detail each of it, each one of it. So I would like to go direct to okay, now we go at the how to make a machine learn or the rebirth of the neural network. You know, at the mid of 70 suddenly people are not using the neural network. They found out that neural network is unsuccessful. The reason is because they try to solve a general problem. So in the mid-80s, the researcher, engineer, and the expert found that the building an expert system required much more than just buying a reasoning system or expert system shell and putting enough rules in. This illusion about applicability of the expert system even lead to the people predicting that AI winter will severely squeeze funding for AI project. So AI researchers decided to have a new look at network. That is for expert system, as you know that because you can just add the rules in order to develop the system. Okay, so they try to change the researcher, artificial intelligence, try to change to a new look at the neural network, where at the late 60s, most of the basic idea and concept necessary for neural computing had already been formulated. However, in the mid-80s, the solution emerged, which during that time, major reason for the delay was not technological. There were no PC and powerful workstations to model and experience with the artificial neural network. As you know, the process of learning, you require quite a powerful computer system in order to run to develop the neural network. Okay, some of it I'm not going through. I think I will use all the breakthrough for the neural network. Okay, this is the era of the late 80s. Okay, I will pass this slide. You can go through. This is the motivation of the artificial intelligence development before this. Okay, you can go through all the slide. Okay, and then before this also we look at fuzzy. Okay, in summary, where the expert neural and fuzzy system have now matured and have been applied to a broad range of different programs. Uh, Example in engineering, medicine, finance, business, and management, where each technology handles the uncertainty and ambiguity of the human knowledge differently, and each technology has found its place in engineering. They no longer compete rather than complement each other. Okay, for example, nowadays you can have a hybrid artificial intelligence. Example. Okay, this is just the summary of history of the artificial intelligence, where we can go through which part the successful in certain area and the dark age in certain area. Okay, now I will end uh, my lecture. Thank you for listening.